Hi, I'm Daz. Today's a bit different. I think you may have seen my video a year or two ago that I made about my solar powered lights in the garden. I need to replace the controller because I've now got gel batteries instead, and plus I suspect that the controller is not quite working how it should. So I took a decision to buy a controller, then another controller, and then another controller until I found one I liked. So here follows some of the hair pulling moments, and well, I haven't got any, that I went through trying to find a controller that actually works. And I think it tells me something that you get what you pay for, basically. So there we go. But anyway, enjoy. Some background information of what my brain is trying to work out with the solar controllers I'm testing. With lead acid batteries, there is several types that you've no doubt seen. You've probably seen the flooded type, where you can top up the battery. Older technology, I guess. Nowadays you get the gel batteries, which are sealed, and you also get the flooded type batteries, which are sealed. In other words, there's nothing to unscrew in order to top up the water. So if you've got a sealed or a gel battery, you've got to be a little bit more careful about how much you charge it and keep charging it, because water loss can't be replaced. The flooded one, of course, it can. So the problem I have is with the solar chargers, which only have one switch point, because to really charge the battery properly for cyclic use, you want to be going somewhere between 14.2 and 14.6. But then you want to be floating it really at around 13.8 in order to stop water loss. So if you've only got one switch point for the solar controller, you're going to have to really choose around 13.8. Otherwise you're going to risk water loss. If you've got a system which is only going to be used for a few days at a time, it's fine. But if you've got a battery bank, so I've got a couple of battery banks here, one for my amateur radio and one for my garden lights, so I really want a charger that will charge it right up nicely to about 14.2 if I'm using gel, or around 14.6 if I'm using a toppable flooded cell, and then switch back down to float. So what I'm looking for is a trace that goes up to around about 14.2 and holds that for a while and then sinks back down to 13.8. And further complicate things, there's also something called Equalization Mode, which I've used on some of my older batteries from time to time. And that's where you take the voltage a little bit higher, and you shouldn't do this with gel cells. And that helps balance the cells out, because unlike lithium batteries, there's no balancing mechanism. So you need to balance the cells out from time to time in order to keep them balanced. And that really only wants to be done once in a while. And of course, I know the really expensive solar controllers probably do that, you know, by counting the days since it did it last. So yep, so this is basically what I'm looking for. So I'm really looking for a charge controller that will go up to a higher charge voltage for a while, hold it there, and then drop down to the float voltage so that the battery is maintained but doesn't cause excessive water loss. Today I'm fiddling with solar controllers and just doing some tests on them. They don't seem to do what I'm expecting, so I'm doing some load tests, etc. When it says it's got a 3-state charger, I expect that to work, but I'm just not getting it to work, so I'm going to do some tests. So just going through this controller, when it's sitting there it shows the battery voltage, the temperature and the PV voltage, supposedly, and then you can go around the menu yourself. That's load, connect and disconnect. That's the timer, or for the load. That's the battery voltage, 12 or 24, and that is your float voltage. You just hold the button down and you can find it. I got that wrong, haven't I? Oh, there we go, off it says. There we go. If I just hold you can change that float voltage, which is useful, but like I said, and then you just, there we go. It's a bit non-intuitive because up is on the left and you just hold it in. There you go. So that's just how you change the settings, but There we go, so that's the basics of this controller, I guess. Well, I've discharged the battery on a load, and the purpose of this is to see if doing so will initiate a 3-stage charge on this controller. I've got a resistor just to simulate a solar panel, so I'm going to try charging now. Just having a look at this graph, you can see it's come up to charge and then it's just floating at the float voltage. If I just go backwards on this data here, there we go, you can just see it gradually creep up. 14, around about 14.1. That's where I turn the charge off. So yeah, that doesn't seem to be doing a 3-state charge, if you ask me. Just looking at the instructions here for the green charger, and definitely it says there float charge and equalization charge, so that's interesting. And looking at the product features, it definitely says there fully 3-stage PWM charge management. I don't remember seeing that happening. Nice hot day, so I'm going to try a real panel. So I've got the solar panel connected to this controller, so we can see what happens. Well, we're going up to 13.7 here, so if this works as it's supposed to, it should take it up to 14.4 first and not regulate at 13. According to my multimeter, the PV at this voltage for some while now, and the PV voltage is saying around 14. So I'm going to measure that. According to my multimeter, the PV voltage is around 16.5. That's not what this controller is saying, is it? Okay, I've just altered the set point, and yeah, it just changes what the battery's sitting at. So I definitely didn't see a equalization charge on this test. Okay, so this is another PV charge controller that costs similar to the green one that I've been looking at. Again, it's very similar. Got a temperature readout, so it supposedly compensates. This one's got addition of an amp meter, but the amp meter only reads when you're over half an amp, which is strange. But again, I will set it up the same side, 14.2 set for float before. Load on was 12.6, so I'll just fiddle with that. Load off was 11.2. Set that the same. And I'll just see how this one works. This one's got an arrow for the load, so yeah, that's load on off there. So I'll do a discharge test again, back down to it switches off, and then I'll charge up and see if we get any equalization. I get the impression this one's got equalization. One problem I can't understand is, according to the manual, when you go around this menu, there should be a menu to set the type of battery for the float, but I cannot find that setting and it doesn't come up. So just looking at the manual for the blue type charger, as you can see, it says here setting available, battery type. Well, I can't find that. I've tried pushing all sorts of combinations of buttons in case it's locked out or something, but I just can't find that at all. There's the amp meter working, 3 amps, which is exactly what the load is that I have on here. Just coming up to full charge, and you can see it's just levelling off again, so just a on-off switch again, no equalization charge, and no boost charge. So again, this is just an on-off controller, the looks of it. Voltage is just holding steady. Okay, so I've got the other controller in now, so we can see what current we've got. 1 amp going in. So let's see what happens now. Looking at the PV voltage, I'd say it's already hit regulation. The interesting thing is the battery voltage is reading, yeah, so there's an error there already, 300 millivolts, so slight error with this one, but again, I haven't seen it go into an equalization charge. It's just stopped again at whatever is set as the PV off voltage. And so on to yet another solar charge controller. This will be number 3. So this one has got amp meter and voltmeter, and also kilowatt hour meter, which is nice, as well as load control again. So apparently if I put this round to the battery voltage and hold set, there we go. Now I'm going to select sealed, gel or flooded battery, so that's good. So this is a gel battery, that will turn off the equalization charge. Good. Okay, so we're in draining mode now, and it's just cycling round the parameters, and there's nothing, I've got no input, so that's blank, and hopefully it'll come round to battery in a moment. 12.1, it's looking about right, and minus 2.8 amps, so load is showing us on, and moon meaning no solar inputs. There, it looks all very good. Yeah, I think the battery calibration is a lot better on this one, but it's flattened and switched off, so it's flashing a warning now. You can't adjust the disconnect or the reconnect, that's fixed. I think it's 11.1 and 12.6, so I'm now going to give it some charge. Oh, nice picture of a solar panel lit up. Just see what happens now. Ah, PV 20. Oh, and then drop to 12. Ah, now that's working. 1.7 amps. Yeah, that looks good. Right, see what happens. Oh, look at that. The PV voltage is even reading right now. It's regulating. That's good. Looking at the data I got from the white controller, you can see the battery charging, and it stabilises at around 14.2, which is what we want, and then after about 2 hours it then drops down to trickle charge voltage 13.8, and then goes down there where I switched the charger off when I was finished. So yeah, that is definitely doing what I want, this charger. So it's stabilising, and it does an equalization charge every day, it seems. So every time the sun comes up, it does 2 hours of equalization, well, not equalization, sorry, boost charge, and then does a trickle charge of 13.8, so it comes on 14.2 then 13.8. I'll put it on flooded and it goes up to 14.6 rather than 14.2, but I didn't see any sign of equalization charge, so perhaps if you run it for so many days it counts up and does that, but I don't really know at this moment. But yeah, I'd say that this controller is the one I'd like to use. Okay, so it costs twice as much as the other two I tried, but it does actually do what it's supposed to do. So yeah, I'm quite pleased with this one. So that's the... Well, I think you can see that it's now going for a equalization charge. We're up to 14 volts already, 1.6 from the panel. The thermometer seems to be taking a little while to catch up. It's still saying 25, but there is a slight error between the voltmeter and this, so this one is reading slightly high. Well, at least the PV indicator is reading correct, because it's starting to regulate now. I suspect that what I've overlooked here is that there is a socket here for a sensor, and I suspect that you may have to connect one up in order for it to get a temperature reading. Another controller I found laying around, which I think came from Mapling when it closed down. This one is designed for 2 batteries and doesn't have a load output. I believe this one is a switching type, whereas the other ones are pulse width modulation types. Well, now it's the turn of the black 2 battery controller. Nothing much happening on the lights, but turn on the power supply. Charging lamp has now come on, and it's a bit hard to see the lights, but yeah, that's lit, and nothing else at the moment, so I'll just log that and see what happens. So just looking at the on-off black controller, you can see that the charging voltage come up, then the switch turns the charging off and the voltage on the battery drops back again. And if I just go forward again, there we go. So it's gradually discharging and then comes up to charge again. Now this controller says it's 14.2 off, 12.9 on, but looking at the evidence, it's about 12.57 that it switches on. If I go back through my data, it's about 13.8 that it ceases charging. But it does say plus or minus 7%, so I assume that's going to be within range. But I suppose the other advantage of this controller is it doesn't cause any radio interference whatsoever, being just a switch. So, of course, if you're a radio ham like me, the only problem with these pulse width modulation controllers is this. I must admit that's a more quieter one, this one is. It's good, it's probably got some suppression in it. That one's awful. This is my old controller, and as you can see the voltage is only 13.1 on trickle. And I suspect what's happened over the years that the output voltage has gradually changed for some reason. So I don't believe it is fully charging the batteries. So apart from noise from the computer, it's completely silent, so it's actually ideal for amateur radio use if you're using HF. The other thing is, of course, that PWM is supposed to improve the life of your battery. The PWM is supposed to be a bit like using a desulfonator, where you're putting pulses in the battery, but I've got no evidence whether that helps or not. I've swapped out the old BP panel and got a new 40 watt polycrystalline, so that should hopefully give a little bit more power during the winter. Here's the battery array that I'm now using in the shed light system. There's 4 6-volt batteries in here, each 10 ampere hour, in a series, then paralleled through separate fuses just in case one pack goes strange. They're gel cells. They've been laying on the shelf for at least 3 years since I've gifted them. I kept them charged, but I thought, well, they might as well be used, because otherwise they're just going to sit there being recharged and never used. And the cable you can see there is the temperature sensor that's in between all the batteries. Well, I've put the new controller in, but I've still got a problem to solve on. I've got the other controller had 2 light outputs, so one of my lamps that runs dusk to dawn isn't at the moment, so I've got to make some sort of controller for that. The controller's been holding at 13.8, but as the sun goes round now, the panel isn't as illuminated, so the voltage has dropped to 13.6, but seems to be working very well. And as you can see, there's a temperature sensor plugged in now, so I've now got a reading. That's an extra expense, unfortunately, but I think this is quite a nice controller in any case. I'm just rummaging around to see what parts I can find. There's a night light here, so there's a night sensor, or CDS, that I can use, perhaps to make a on-off switch. This is the old controller, and you can see it's got 2 lighting outputs, very unusual. Well, what a mess I've made here. Found a FET, that's all I really needed to do this little job, but the only slight problem I have is there a very slight glow when it's switched off, but I'll explain why in a minute. I'm quite surprised there is, but if I just cover up the, there we go, on, off, on, off, on, off. So there we go, I've got my photo switch. Just looking at the circuits, zoom out a little bit, there we go, and just get out of the way of the wire. That's what I had. This is what I've done. I've had to put a resistor in here because I didn't want too much base current going into this transistor, obviously. 47k N-channel enhancement MOSFET I found in a drawer. Just used my component analyzer to see if it was what I was looking for. And what I've done, which is why you can see the lamps glowing slightly, is, if I just draw it in around there, I've put 150k there from the output to the base, which is why you saw the LEDs glowing very slightly. 150k, and they're glowing fractionally. Incredible that, isn't it? That must be microamps, but that gives a bit of positive feedback so that you get a nice positive on off. Otherwise the FET's going to turn halfway on. Not a problem with the load I've got because it's only about 30 milliamp, but it's just nice for it to switch on and off. So there you go, a little while spent just modifying an old piece of an old night light, and I've got something suitable for 12 volts. I've boxed up my Dust Dawn circuit board. I reutilised the little grommet with the window on. I've just stuck it next to the window in the shed, and that should just switch on the auxiliary light while it's dark. That's been up for a good few years now, showing signs of deterioration, but it's just got a few white LEDs in it. That just lights up above the shed door. This is my amateur radio battery bank, as you can see. Bit of a mess, a big wooden box outside. There's a shunt for monitoring, and the solar controller lives in there. You might notice some inductors try and reduce the interference from pulse width modulation. Here's the solar controller in the battery bank, very simple one, but it does have a 2-level charge system, so it does the job. It's just got one flashing light and that's it, so a bit boring. These are the unit inside that's connected to the shunt. It's rolling a bit because the I've got a mobile phone on charge at the moment. And these are the 220 watt solar panels driving the amateur radio battery pack. And the wire you can see is my 80 metre aerial, which has fallen down due to a screw chewing through the pulley rope. Oops. Here are the batteries, and the reason I've got them open at the moment is I'm just going to check the electrolyte level, because these are flooded cells and they are actually ones you can top up, which are getting harder and harder to seem to get now, but indicator showing green. Well, at least I know one cell's adequately topped up. A bit of a risky shot filming down the top of a battery. One spark and could be trouble, but you can see there's a plastic marker, and you can see the electrolyte is below it. Needless to say, when doing this, goggles and protective clothing is essential. So there we go, so I will need to top these up. Well, there wasn't much change out of that bottle of distilled water, 1 litre, especially the 85 ampere hour. It's quite thirsty. But then at least I know my power packs, well, my battery, sorry, is now maintained. With the uncertainty of a lot of things in the world at the moment, it's good to know I've got some batteries to back up my radio station should I need it. It's always good to have. Not much point in having an emergency radio system if it relies on the mains, really, is there? I've also got a small sine wave inverter, so that's useful to have as well. And this mess you can see here is my lightning arresters for my amateur radio aerials.